This is the video guide for Class 2 Assignment 2, the third map, which is going to be an extra credit map. And in this map, we're going to actually be using polylines as opposed to points. We've been using points up to this point. We're going to use a different file type. We're going to be downloading our data from the USGS hazards program, which we're familiar with at this point, but we're going to be using the Shakemaps. We're going to be downloading the GeoJSON intensity contours. Once we have those downloaded, we're going to be working with a base map. We're familiar with this base map. This is the 1 to 10 million shaded relief base map. We're going to convert to a shapefile format using a utility called MapShaper. We'll orient to ArcGIS and connect our data. We'll be making a map in 8.5 by 11 format as opposed to the larger formats we've been using up to this point. We are going to also utilize what's called a layer file, which is, we haven't used this yet. This is a reference file that helps with symbology. We can store symbology in this particular layer. So we'll discuss this in depth. We'll also talk a little bit about red, green, blue, and hex color codes that we can utilize in map making. We're going to develop our map at the 1 to 10 million scale. We'll work with our legend and manipulate via a graphics format. We'll develop our final map layout and then export the assignment map, and you can load it with your other maps for this particular assignment. So 10 steps to get us to the final. And we can simply start with our Class 2 Map 2 to get started. So I have Class 2 Map 2 in front of me loaded, and we can deconstruct this map a bit to get set up for our third map here. And the way that we can do this, we need to go ahead and make a 8.5 by 11 sheet. So I would go to Print and Page Setup. We're going to be in Portrait, and let's make the width, actually we could just make it a letter. Should be here. There it is. Because that's going to give us a smaller sheet. So I'm going to move over my insert map frame. I'm also going to make this smaller. Probably have it in about the same position now. So once again, I'm going to do a bleed across my page. So I'll make it a little bit bigger than the page edge. My legend, I'm going to, actually I'm going to get rid of the legend for right now, so I'll delete that. The title, I'll just keep up here. I'm going to change that title in a bit. Scale bar, I will put over here. My source tag I'll put here. This is off the page. I'm in layout view right now. I'm in layout view at about 50%. So somewhere my north arrow went missing. Here it is sitting over here. I'll stick it right next to my elements here. Okay, so there's my rudimentary 8.5 by 11 portrait setup here. I have some work to do. I'm going to keep the insert map. I'm going to keep the gray layer, the relief layer. I'm going to get rid of admin countries. I'm also going to get rid of my earthquakes and also my annotation from the last map. So we have just a simple base map at this point in our insert map. I also need to get rid of that bounding box because we're not going to use that anymore. So these are the two elements that I have, the insert map and then the base map. I'm just going to go ahead and save this. So save as, and I'm going to save it in my assignment 2 folder, and I'm going to call it class 2 map 3, and maybe underscore EC for extra credit, and save it. Okay, so I'm all set up with my basic parameters in terms of my map layout. So the next thing we want to do is we want to actually go get our new feature component, which is going to be from the USGS program called Shakemaps. So what we need to do is orient to that online. And we're familiar with this site at this point. This is the USGS earthquakes search, and what we can do is, of course, do a search as we've been doing. Another option is to go back to earthquake list maps and statistics, and we have by year an earthquake with a very large magnitude, a very significant earthquake, because what we want to do is we want to symbolize across the full spectrum of intensity. So instead of picking maybe a recent earthquake that has a very low magnitude, we're going to try with this extra credit map to do one of these very large earthquakes. So maybe like top 20 largest, we could take a look at those. So the magnitudes on these very top ones go all the way up to 9.5, and there's many that are in between 8 and 9. So I could click on one of these, and we want to get to each one of these earthquakes. Individual earthquakes is going to have several different components once you actually click on them. And what we're looking for is the Shakemap version. I think I'll work on this one. So you want to click on the Shakemap component. And under Shakemap, this is basically a representation of the actual magnitude of the quake based on a color ramp that's going from 1, which is not felt, all the way to extreme. And this is based on some methodology to develop this particular scale of perception for earthquakes, and we'll talk about that in just a second. So there's a Shakemap manual, which is interesting. You can go through and see how this is all put together. We want to download the actual data, so we want to download the components that would make a particular map like this. So we would go to Downloads, and under Downloads we have many different file types. So many of these are for Google Earth, so these KMZs and KMLs. We have some grids. We have some GIS files that we could put right into GIS. There's the HASIS data program. There's also Esri raster files, so we could do this mapping in raster files. But what we want to do is we want to use the actual JSON version of the contours. So this is just going to be the intensity contour lines. And you'll see it down towards the bottom. It'll be called intensity contours, contours of macroseismic, microseismic intensity. And we're just going to download the JSON version. So we can see that this is a feature collection, and it's made of many different points to make these polygons. And we're just going to simply download this. So I'll just do a right click onto the file itself and say Save As. And I'm going to save this. I'm going to go into Assignment 2, and I'm going to make a new folder. I've actually already have a new folder called Part 3 Extra Credit. I'll put it in there. So I'm just going to call it, I'll just leave it the default, so it's CONT_MI, and say save. Once that's accomplished, I want to go to MapShaper, which is mapshaper.org. And this is one of several online utilities that will allow you to make conversions between one file format to another. So in this case, I want to go from GeoJSON to a shapefile, so I'll do select, and I'm going to point it to what I just downloaded and say open. This, or export it. So we click on export. We want to have it be a shapefile format, and we say export. And it's going to drop down into our downloads. And I'm just going to do a right click and cut it and stick it in my folder for assignment 2 here. I'm going to put everything in this part 2 extra credit folder, and I'll extract it. So there it is sitting right there. That's the feature set I'm going to use in GIS. So I'll go ahead and delete the zip file. Okay, so now I've opened up ArcMap, my map 3 map, and I'm going to point my shapefile to this particular MXD. So I'm going to bring it into my table of contents here. So I'll just add the data, point it to assignment 2, part 3, and I get a warning that my geographic coordinate system is different than my base map. In this particular case, we'll get into map projections in our next class, or actually in class 4, which is 2 classes away. But for right now, you can just go ahead and say close. It's just giving you a warning that's saying that these two layers that are within GIS right now have different coordinate systems. And that's okay for map making purposes as long as we're not doing GIS analysis, which we're not doing. We're just doing cartography. We should be fine. So we just say close. And then we want to, once the file's in, we want to zoom to layer. And here we can see it actually in our map. So I'm going to make these a little bit thicker so we can see them. So these are the contours. And we can see that this is on the coast. And as it goes into the ocean, the contours obviously become very smooth, like a stone across water. Whereas once they hit land, then they are affected by the terrain of the landscape. And we can click on and click off and see how those intensity contours are going to manifest themselves across land as opposed to water. And let's take a look at what type of file type this is. So if we open the attribute table, we can see that these are all polylines. Even that enclosed circle here is a polyline. So the file itself is based on polylines. And importantly, it has several components inside. One is it has a color code, which is called the hex code. And we'll talk about that in just a moment. Its units are intensity. And the value, let's see what it scales from. So it's sort ascending. It goes from 3 all the way to 8.5. So this is an important variable, the actual value. This is a quantitative value that we can associate with a qualitative color ramp that's already been developed or utilized by USGS. And we'll talk about that in just a moment here. So let's do this. Let's set up a bookmark for the scale that we're at. We're using a 10 million base map, and I'm at about 1 to 7 million right now. Let's go ahead and make this 10 million. So we should be designing our final map deliverable at about this scale. That makes sense. And this should be able to capture the extent of your USGS Shakemap contours. And then I'm just going to say File, Save to update my map. Now let's go ahead and take a look at how we would actually symbolize these purple lines. So right now we can't really tell the difference between one contour versus another contour. We know close to the epicenter of the quake that the actual magnitude of the quake is going to be much greater than at the outward edges. And we would like to symbolize that. So if we take a look at the actual Shakemap documentation, the manual itself, there's an interesting discussion about the color palette for the Shakemap. So this is the intensity scale. And the intensity essentially goes from a 0 to a 10, and it has preset colors that go along with those intensities. And we can see that the intensity has been developed into a legend that relates to qualitative understanding of earthquakes. So 1s and all the way up to 3 is going to be not felt and weak. 4s are going to be light. The moderates are 5s. Strong is a 6. Very strong is a 7. Severe is a 8. And violent is going to be 9. And even up into the 10s. Okay, so this is essentially the color ramp that we would like to replicate. And what I've done, and we'll reference in the assignment itself, is I've just made a little chart here that gives us not felt. So it's 0, 1 intensity classes that you'll find in your files, all the way down to extreme. And there's 2 color codes here. There's a hex code, and then there's also red, green, blue. And in ArcGIS for symbology, these codes need to be translated into a red, green, blue. And I'm going to show you right now where that's done. So for instance, if I wanted to, I think we have some 3s here. If I want to go into my open attribute table and I wanted to symbolize this 3 and 3.5, what I need to do is I need to actually go into Properties, I need to go to symbology, and in this case we'd be in quantities, and we would be mapping on the value. So that gives us our, if we wanted to have 5 breaks, we could have more breaks if we wanted to. Let's do 10 breaks and see how many we have. So we can go all the way up to 7 or 8.5 from our first class there. But I'm just going to show you how to symbolize 3.0 here if you wanted to do that. So if I click on 3.0, I get into my symbol selector, and under color, I obviously have these colors, and they have, if you roll over them, they're going to give you a name, which is helpful. If you go to more colors, you have more control. And here's where you have CMYK and also red, green, blue. So in this case, I have this number code, and I just need to translate from the chart, which is this chart. So 3s are a red, green, blue of 160, 230, 255. So I'd say 160, 230, 255. So that's going to be 230, 255. That's a bluish color, and say OK. So we can barely see it. It's on here on the outside edge. And that's the correct color based on the methodology that comes from the Shakemap. So this is down in this color range right here. It's basically the weakest edge of the earthquake, and we can see it's very far away from the epicenter. So I've just classed that particular color correctly. The problem with doing it this way is that you would have to go through many different steps to get all your colors exactly right. So you have to click on, go in, go to more colors, go to red, green, blue, and pop in your red, green, blue codes. There's another way to do this, and you can base your current shapefile layers based on a pre-formatted layer. And I've made one for this particular chart. But oftentimes when you're dealing with shapefiles that have come from an agency, there's a pretty strong chance that you're going to have a layer file. And in the layer file is the symbology that the agency would prefer that the shapefiles be displayed in. So what you can do is you can import that layer file and then basically take the symbology from the layer file and apply it to your particular shapefile that you're displaying. And I'm going to show you how to do that process right now. Okay, so what I need to do is I need to navigate to my Part 3 extra credit folder, and you'll have a link to this layer that I've produced. You just add it, and once you add it, you can see that it gives you an exclamation mark. It's not presenting any geometry, it's just presenting the actual symbology here. And this particular symbology, there's no attribute with it. It's just showing us the correct colors. So our 3 in our actual shapefile is the same color as this 3. And the 10s are the correct reds. So what we want to do is we want to apply this color scheme to our actual shapefile. And the way that we do that, I'm just going to save this map here. So just do a right click and go to Properties. And under Symbology, we can go to Features, just a single type, and we can import the actual layer. So here I'm importing earthquake intensity. And it asks me, how do you want to symbolize this particular layer? And in this case, we're taking the match value, which is this color, and applying it to value. That's just the number that we see here. And say OK. And there it is. And we apply it and say OK. And now we actually have a color ramp that is correct to the USGS Shakemap symbology. So if we go back to the manual, now we can actually see that our color array is in keeping with the perceived shaking color ramp symbology. And we're getting pretty close at this point to producing this map. And I've made these particular lines to be 1.5. It's a little bit thicker than 1. 2's a little too thick, so 1.5 works pretty well for this map. So what I need to do now is, once I have this mapped, I'll go ahead and save it. And I would need to go back at this point and make sure that my titling is correct. So we want to title the earthquake, what the earthquake's name is. We also want to say what the magnitude is, its date. So we want to definitely change our titling around. So what we want to do now is we want to actually start to develop a legend. And this is a new way to develop a legend that we haven't talked about yet. So if I go to Insert and select a legend, I'm going to put everything into Map Layers, and I'm just going to bring in my actual Shakemap contours. Put this in. Next. Next. Finish it. And if we take a look here, we'll notice if we look in our attribute table, we only go from 3 to 8.5. So if we want to trim down some of these breaks, some of these classes here, we can do that graphically. And what we can do is we actually can take this particular legend, and we can do a right click and we say convert to graphics. And as we convert to graphics, now this becomes an editable file that's now separated from our original table of contents. But before I do that, what I should do is I'm going to redo this here. I'm going to delete this, and I'm going to put in insert a new legend. And what I want to do is I want to copy and paste this. So I have an original one that I can always use if I want to. So I'm just going to say copy and then say paste. So this is going to sit over to the side. It's going to be active and live. This one's going to change into a graphic. So it's going to, as soon as you convert it to a graphic, all of a sudden it's no longer attached to table of contents. So if you change something in table of contents, it's not going to change it here. But what happens here is that if we keep ungrouping this, so we can click on the elements and we can say, like, legend now becomes editable. So I might want to call this something like earthquake intensity. And here I might just want to get rid of this. You can see what happens though. Nothing's changing in my table of contents. This is just the editable feature now. So now I might want to get rid of all these guys. So I'll just delete these ones, delete, because remember, we are only, in our data set, we only have 3 to 8.5. We need to make sure that that's the case. So we go open attribute table. Yes, 8.5 is our top class. And it looks like we have everything in between 3 to 8.5. So here I could delete this one, delete this one, ungroup it, and then go into the text. And 3, I could just put a break, and if I go back to my chart, intensity chart, a 3 is weak. So I could, if I wanted to, I could put in weak, and just go down from weak all the way to extremely strong, classing this particular legend. And then what I could do is bring this down, and now I have graphical control over this particular legend, and I can nudge things around. I can make a really nice clean legend. And once I'm actually finished over in this white space, what I can do is I can group everything together, and then I can move this around now. So, and then of course it scales as I group it. So this is one way to get a lot more control visually over a legend. But the key thing is that it's no longer attached to the original legend. It's become a graphical feature at this point. If I want to change something over here in my table of contents, I want to change my titling over here. Let's call it intensity. You can see that it changes in the original legend to intensity because these two have a relationship as a legend item. So I kind of like to keep these off and to the side until I'm ready to produce the final map, and oftentimes I even leave it just sitting there over on the side to come back later if I need to, and I just do a file save. I also probably want to set up a bookmark at this point, so I'd say bookmark and create a bookmark. This one would be map 3. I'd say OK. And then what I need to do is I need to develop the map page at this point. So let's go to map layout at, say, 40%. And this guy stays way over here. I'm going to have to make my insert a little bit smaller. If I'm going to fit this legend in down here, I'm going to have to make him a fair amount smaller. Maybe I'll put him like that. My north arrow could be a little bit smaller too. Definitely want to make this guy smaller. So I might go down to 300 miles. And my source tag, I might change the font size of my source tag. But yeah, I'm not going to spend a lot of time developing this further. I just want to show you how you can kind of move things around here. So you're going to want to spend some time and make sure in terms of your map layout that you have a hierarchy in terms of your font styles. So the earthquake intensity for my legend should be bigger than my source tag, and currently it's not. So once again, if I need to go back in and edit this, I can just simply make it active, do a right click and say ungroup, and then I have access to it. And right now it's 9.64. Probably want to make that Arial 12 maybe. But you get the point here. These are all now editable. I'd probably make a new scale bar. This one seems to be too big relative to the space that it's sitting in. And the last thing we want to do on this particular map is that we would want to, like we did for map 2, produce a bounding box and do a map insert, because at this scale, once again, we don't have a sense of where this map actually is. So I'm going to skip on doing that step for this video. We covered making a map insert with a bounding box in the second map, and you would do the same process here. You would just make sure to get a bounding box for your geometry, for your intensity geometry, and then you would drop it in and symbolize it into your insert map. So now we have a map. We'll do our correct titling for the name of the earthquake, its intensity, and its date. And then we can actually see on the map the actual contour, the shape contour of where this particular earthquake hit and how it related in terms of intensity to both land and, in this particular case, to water.